Welcome to 57th lecture. 57th lecture on circuit analysis. And in this lecture, we are going to study Y-connected three-phase source or load. We have been studying this three-phase Y-connected source and load for the last one or two lectures. In this lecture, we will solve an example where we are given a line voltage. This is a line voltage that we are given VAB. In last lecture, we studied about line and phase voltages in a balanced Y connected system. Right. So VAB is given to be 208 at an angle of minus 30 degrees. And we are asked to find the three phase voltages. We know VAN, VBN, and VCN are phase voltages we studied in last lecture. CA56, CA56, right. So before we find VAN, VBN, and VCN, we have to go through a small recap from last lecture. This recap is from CA, lecture CA56. So let's see what this recap is. We know that the set of phase voltages VAN, VBN, and VCN are represented with the same magnitude, and they are at 120 degrees apart from each other. VBN is lagging VAN by 120 degrees, and VCN is lagging VBN by 120 degrees, or VCN is lagging VAN by 240 degrees. We have also studied that minus 240 degrees takes us to the same point where we find ourselves by moving plus 120 degrees in counterclockwise direction. If we move 120 degrees in counterclockwise direction, we reach to the same point if we move 240 degrees in clockwise direction, right? So moving 240 degrees in clockwise direction takes us to the same point where we reach by moving 120 degrees CCW counterclockwise, right? And we also studied in our last lecture that we have a set of line voltages. This one we represented VAB, VBC, and VCA, which is the magnitude is under root 3 times for each of these three voltages. The magnitude is 1.732, which is square root of 3 times VP, and VAB is 30 degrees leading VAN. Similarly, VBC is leading 30 degrees VBN, and VCA is leading VCN by 30 degrees. Right, so all the line voltages are 30 degrees leading the corresponding phase voltages, or in other words, all phase voltages are 30 degrees lagging their corresponding line voltages. Right. So let's move on to the problem where we are given this line voltage VAB, and we have to find the set of three phase voltages. Right. So let's divide VAN, the first phase voltage that we wrote here, divided by this first line voltage VAN divided by VAB. So if we divide the two, this VP cancels with this VP, and now we have two complex numbers, 1 over square root of 3 at an angle of minus 30 multiplied by VAB, because we have taken VAB on the other side of the equation. Right. So now VAN is VAB. Let's put the value of VAB, that is given 208 at an angle of minus 30 multiplied by this complex number that we obtained from here. So now VAN is 120 degrees at an angle of minus 60, because 208 divided by square root of 3 gives us 120, and minus 30 is minus 60. We know when we multiply two complex numbers, and both of them are in their polar forms, the magnitudes are multiplied and the angles are added. Right. VBN is 120 degrees, 120 at an angle of minus 60 minus 120, because we know that for a balanced three-phase system, VBN is 120 degrees lagging VAN. And similarly, VCN is 240 degrees lagging VAN. We studied in last lecture. So in this way, we can represent VBN and VCN. And of course, all of these voltages, phase voltages, have the same magnitude VB. And there is another important point to note, that minus 300 degrees takes us to a point where we are reached by moving 60 degrees in CCW counterclockwise. Takes us to the same point. And this is the same point where we reach by moving 300 degrees clockwise. Right. So VCN can also be written as 120 volts at an angle of plus 60, because minus 300 is the same point as plus 60. Right, that's all for this lecture, and in the next lecture we will study more about balanced three-phase system. Thank you.